Now let's talk about how technology for radioactive waste management has evolved over time and continues to as we learn from our experience and integrate higher technology tools and we continually adapt. Our next session explores the management of waste, how it has changed, and how innovation in this field is now more exciting than ever. The chair of this panel is Bharath Nangia, and he's the Chief Innovation Catalyst at Nuclear Promise X, a startup with its headquarters in Bruce County. Bharath is a mechanical engineer who started his career in the automotive industry before pivoting over to nuclear. He's played a key role in the Bruce 1 and 2 restart, and he is passionate about applying nuclear solutions to address climate change. We're glad to have you here, Bharath. Please proceed.
Thank you, Corinne, and good afternoon, everybody, and welcome to the Innovation in Waste Management panel. This has been such a great summit so far over the last few days. I've had the pleasure of attending many sessions, so many different viewpoints, different perspectives, and here we are today. Thanks for sticking with us. I know it is towards the end of the conference, Thursday afternoon, before the long weekend, on April Fool's Day, but I assure you, this is one of the most exciting places you could be right now. Today we're talking about one of my favorite topics, innovation. And certainly there is a lot of it to talk about in our industry. Our existing utilities plants are setting operational world records for safe, reliable generation. We're producing isotopes, and Canada is becoming a world leader. Vendors are introducing new technologies every single day. So lots of innovation, and I heard somebody say the other day, the rate of innovation has never been this fast ever before. And I love that, and it makes me feel like we can solve any problem through fresh thinking. But I'd like to rephrase that in a slightly more exciting way and say that the rate of innovation will never be this slow ever again either. So with that, I'd like to introduce our really exciting panel today. With us today, we have Carla Carmichael. Carla is the Vice President of Nuclear Decommissioning Strategy at Ontario Power Generation. Carla oversees the program for safe, cost-effective, environmentally and socially responsible decommissioning of OPG's nuclear legacy by focusing on strategic and innovative solutions. Carla's played a lot of crucial roles at OPG previously, including VP of Commercial Management and Project Assurance at the Darlington Refurb Project, as well as VP of Nuclear Finance. She's currently also a board member of the Can-Do Owners Group, the Durham College Foundation Board, and is an active member of Women in Nuclear. And in her free time, in all her spare time, she mentors many women and men in our industry, and I'm fortunate to say that I have her as one of my mentors as well. Welcome, Carla. We also have today with us Jeff Richardson, another mentor of mine. I'm pleased to share. Jeff has over 30 years experience in the nuclear power industry. He's played a variety of roles at Entergy in the past. These included power upgrades, licensing, corporate re-engineering, new plant development, and mega project management, which is where his next role was at Darlington Refurb at Ontario Power Generation as the lead for the Darlington refurbishment project, a very big success story for our industry. And Jeff is currently the Chief Operating Officer of Energy Solutions, leading the US and Canadian waste management and decommissioning business lines. In case you're interested, Jeff also provides some of the best book and podcast recommendations, so please feel free to reach out to him for that. Moving on to Alastair MacDonald. Alastair, you see a trend here, right? If you weren't a mentor of mine before this panel, you will be after it for sure. Alastair also has over 30 years of experience in the nuclear industry. An engineer by background, he has operational, power plant, project management, program management, and reactor decommissioning experience. Most recently, he was responsible for a complex nuclear material packaging and transport project at Dounreay in the UK as part of his role with Cavendish Nuclear. And Alastair is presently the Vice President of Decommissioning and Waste Management at AECL, where he oversees areas including facilities decommissioning, waste management, and land remediation across all of AECL's sites. And finally, we have Dr. Brian Ikeda, who is an associate professor at the Faculty of Energy Systems and Nuclear Science at Ontario Tech University. Brian, you were one of my professors. That counts as a mentor for sure. Brian's PhD is in electrochemistry, and he has a lot of experience studying corrosion in the nuclear industry. He's previously also worked in the nuclear fuel waste management program at AECL's Whiteshell Labs for almost 25 years before moving into his current position at Ontario Tech University. So welcome everyone. It is my pleasure today to present this panel to our team, to our participants. Our format today is we're going to have each of the speakers present their organizations and innovation as it pertains to their organizations for about 5 minutes each, following which we'll move into about 15-20 minutes of Q&A. And I'll invite throughout this session, if people want to put in their questions in the chat, we'll be keeping an eye on it and making sure we answer as many of those. So with that, I will present to you Carla Carmichael from Ontario Power Generation.
Thank you. Thank you for inviting me to be part of this innovation panel for the Canadian Rad Waste Summit. Before I begin, I would like to acknowledge that I am in the traditional and treaty territory of the Mississauga Anishinaabeg. One thing that Bharath didn't mention about me was that I am a strong advocate of nuclear technology and its value to the electricity and health sectors and the environment and socioeconomic fabric of Ontario. I also live and have raised my family in the Durham region for 30 years, within 10 minutes of the Darlington Nuclear Station. So next slide, please. I believe that the most important topic in waste management, and specifically innovation in waste management, is collaboration. Combining expertise to research and develop successful solutions for areas of opportunity that exist in the nuclear life cycle, including the end of the life cycle. OPG is constantly looking to embrace new technologies through innovation. We believe that an innovation is essential to achieving success. The time is right to build up capabilities in decommissioning CANDU nuclear stations, as OPG plans for the end of commercial operations of the Pickering Nuclear Generating Station beginning in 2025. CANDU is a made in Canada technology. We have opportunity to be leaders for its safe and socially responsible decommissioning and create a made in Canada solution for the end of the life cycle. Next slide, please. As such, OPG launched the Centre for Canadian Nuclear Sustainability in October with a goal to bring the industry together to collaborate on innovative and sustainable solutions for nuclear, with an immediate focus on the end of the life cycle. The Centre will provide a hub to lead the nuclear industry to innovative opportunities related to decommissioning and nuclear material management. Our vision is to ensure nuclear technology is adopted as a sustainable energy source for future generations by forming partnerships with the industry, community, local businesses, academia, and Indigenous communities to discover, research, and further develop innovations and technologies. We're also engaging at the international level to learn from organizations on their best practices and lessons learned. The Centre will look at OPG's current decommissioning plans to identify areas of opportunity to ensure safe and socially and environmental sustainability. At OPG, we embrace the 3 Rs. We reduce, reuse, recyclable nuclear byproducts. We will be looking at fleet-wide solutions for permanent disposal of nuclear materials with a continuing emphasis on minimizing environmental footprint. This includes minimizing material production at source, innovations in processing to reduce volumes, and diverting and recycling clean materials. Next slide, please. At OPG's center, we currently have about 40 partners that we are currently collaborating with. In addition, just this week, we announced a collaboration with Moltex Energy on a project aimed at recycling used fuel from CANDU reactors. This exciting project will look at how we can extract the remaining energy source and prepare it for use as new fuel in other advanced reactor designs, potentially reducing the cost and volume of material that needs to go into a deep geologic repository for long-term storage. The work we will contribute to the development of Moltex technology, which could lead to more sustainable form of nuclear power. This is a great example of collaboration, as there are a number of organizations involved: OPG's Center, Canadian Nuclear Laboratories, the University of New Brunswick, and New Brunswick Power. We also recently announced OPG's subsidiary Laurentis Energy Partners is in a research partnership with McMaster University to find new ways to sort, segregate, and recycle materials. In addition, last year, the same Laurentis also announced a partnership with BWXT to develop technology that would clean heavy water, which then diverts the volume from becoming nuclear waste. The journey we are embarking on with all of our partners demonstrates that collaboration is an integral part of the innovation journey, and no single organization can do this alone. We really hope to foster and encourage teamwork and partnership that expands beyond just the nuclear industry to include community, Indigenous groups, and other types of businesses and academic institutions. We really want to capture brilliant minds and ideas, which we can then apply to the nuclear world. Thank you.
Very much, Carla. And with that, we'll turn it over to you, Jeff.
All right. Can you hear me all right?
Yes, we can.
Very good. Very good. Well, good morning or good afternoon, everyone. Very great pleasure for me to be here. As Brad said, Jeff Richardson, Chief Operating Officer at Energy Solutions. And I can tell you that having only left OPG about 6 months ago, I feel very strongly connected to my OPG friends and colleagues, as well as others in the Canadian nuclear business that I had the pleasure of working with over the last several years. And I wish I could be back there with you, and hope to be soon as we work through hopefully what will be the final stages of the pandemic and our societal response to it. So I look forward to that time to be together face to face in the future.
Thank you so much, Jeff. And, you know, in the innovation sphere, we would say those are the brave ones that try something new out and take the risks and so on. In today's world, we'll say the brave ones are the ones that try to play a video over a summit presentation. So well done there, Jeff. Thank you. And Alastair, we'll turn it over to you.
Sure. Well, thanks very much. Hope you can all hear me quite well over there. First of all, I would like to acknowledge I'm sitting here in unceded Algonquin territory right now, and I would also like to thank NWMA for inviting me onto this panel today. I really appreciate being part of this conversation in Canada. Bharath, thank you very much for the introduction. I've been in Canada for over 2 years now, and the majority of my experience has been gained at the Dunray site in the north of Scotland, which has very similar legacies to that which we have in Canada at the Chalk River site here. You can see in this slide here the topics I'm going to cover in the next couple of minutes. Start off by saying AECL, we are a federal Crown corporation and an agent of the Crown. Our mission is to enable nuclear science and technology, and we're building some exciting new laboratories and facilities at Chalk River right now to enable this for the future. However, I think importantly for this current conversation, we have a responsibility and an accountability to manage the legacy wastes across all our sites. We provide the funding from the Government of Canada to Canadian Nuclear Laboratories, or CNL, to execute the various projects we have to move forward with our missions. You can see from the map here where our sites are located, but much of our waste, particularly the low-level wastes, are at Chalk River, with also significant volumes of waste associated with the Port Hope Area Initiative. I've mentioned Chalk River a couple of times. The photograph here shows the built-up area, which is a small part of the overall site at Chalk River. This was and still is Canada's nuclear S&T centre. It has been since the 1940s and 1950s. Because of the length of the time and how approaches have changed over the years, this has given rise to, I would say, quite a wide range of waste that have been stored in a wide range of forms in various places across the site. And already, since over the last 5 years, we've decommissioned just under 100 buildings on site. We have many more left to do. And over the last few years, the teams at CNL, working with the supply chain and also in collaboration, listening to Carla, and to Carla's point, they are collaborating with many others. We have built up a capability and a capacity to enable the decommissioning at the site. So as far as low-level waste is concerned, at both Port Hope and Port Granby down on Lake Ontario, we have engineering containment mounds in operation. Each of those mounds has the capacity for about 1 million meters cubed of low-level waste. At Port Granby, the mount is full and currently being capped. It's ready for long-term monitoring. At Port Hope, it's further behind there, but the containment mound is in operation. At Chalk River, we support CNL and their proposal for a similar facility, which is currently undergoing environmental assessment and licensing process by the CNSC in Canada. The white building in the middle of this slide actually exemplifies some of the challenges we have from historical work. This is a building which has had various processes over the years, has used a range of material and is partly constructed of asbestos and has got some contamination throughout the building. And this drives our innovations. We seek really not to rush our projects, but plan up front. And this drives continuous improvements in the way we characterize all our wastes and materials. It doesn't just apply to buildings. There's historical materials that we've placed in trenches and bunkers. We employ a range of techniques to improve the understanding, both invasive and non-invasive. Our aim is to minimize surprises. And then for some of the material that's already packed many years ago, we're going back and assessing with the objective of sorting the material that's clean and segregating that from the low-level waste, again, minimizing the waste that we place for disposal. And at Chalk River Labs, we've built a pilot sort and seg facility, which is shown here in the yellow picture, where we are learning lessons from this pilot facility. We've also built a larger facility, which we'll continue to use, and we'll take the lessons from that pilot facility and feed that into the larger facility. And we would always advocate applying a measured approach to basically ensure that we minimize the waste throughout here. For intermediate level waste or ILW waste, our waste volumes are relatively small compared to, say, the power plants. But what we're doing right now is assessing the options available to us. In advance of that, we're also spending time to improve the characterization of the material that we have. We're taking some of the material that we have already in facilities, and we've recently packed them into some self-sealed packages that are disposal ready. And you can see some of the photographs at the bottom of the slide that show that. This is an approach that we have taken from Europe, and it just sort of reinforces the strong driver that we have to learn from others where we can. We're also in the very early stages of developing solutions to retrieve historical ILW that's stored in the ground. At Whiteshell, we have a project in the fabrication stages, and that's to retrieve material from tile holes stored in the ground, and then we'll apply the lessons from that project at Whiteshell to the larger volumes of material that we have at Chalk River. So just to finalise here, what next? So what now? I mean, quite honestly, we look forward to being part of the process to develop a Canada-wide integrated waste strategy. We can only see a benefit to making sure it's clarified and optimised for Canada. We'll continue to utilise the best technologies we can to characterise, reduce the risks to the environment, public and our workers, and avoid some of the repacking that we're currently doing. As I mentioned at the start, the lab is a centre for science and technology, and we'll continue to capitalise on the knowledge and brains and capacity available to us to aid our decommissioning. And just lastly, I would campaign, it's important for us to make progress. We do not want to leave this for others. As time moves on, the waste and facilities degrade and the risks will become greater. So I think with that, Bharath, back to you. Thanks very much. And I hope it gives you a flavour for some of the work and perhaps some of the innovations that we're looking at. So thank you all very much.
Thank you so much, Alastair. And our final speaker, Dr. Ikeda, over to you.
Thank you, Bharath. And I also would like to thank the organizing committee for asking me to sit on this panel. I'm quite excited about this. So I'm, as Bharath said, I'm from the high-level waste program. I worked in it for over 25 years at Whiteshell. And my area of expertise is corrosion and doing research in corrosion and lifetime predictions. But now at a university, our product is people, highly qualified personnel. And innovation has been part of our university vision since it began. So for those of you who are unfamiliar with the university, we're, I think, still the newest university to be built in Ontario. We came into being on June 27th, 2002. And after a very mad construction season, the first students attended class in September 4th of 2004. So there are seven faculties at the university, mostly related to technology. We have over 19,000 alumni, and our current student body is about a little over 10,000 graduate and undergraduate students. And this is a few of the university. This is our a cooling pond for our geothermal heat pump system, which provides heat to a number of buildings in the university. The Energy Research Center is located right here, which is the building that I'm located in, and it also hosts one of the other facilities that I'll be talking about today. So some unique things that we do at Ontario Tech is, this is Dean Tokuhira here, and he's giving a talk and a lecture to a number of students using the reactor simulator. So we have on site a number of these reactor simulators which run the simulation program. Professor Beresnai is one of the people who pioneered the building of these reactor simulators for CANDU reactors. And so we do provide training and classes for students, undergraduate and graduate students, and also staff in the preliminary training. OPG, of course, does their own training on their own simulators, but this gives a flavor, particularly to graduate students who are interested in helping develop these reactor simulator and training tools. This is not nuclear. This is an experiment which is being done not outside, but inside our wind tunnel, the Climatic Aerodynamic Wind Tunnel ACE, which is located on site. So this is a simulation of firefighters doing some rescue work. And we have done a number of experiments. Our biokinetics group has looked at suiting these people, monitoring these people, and seeing their physical responses to a variety of conditions, which we can do and which we can replicate in this wind tunnel. It's a 4-season wind tunnel. It can go from minus 40 degrees C to plus 60 degrees C with winds of up to 240 kph, which, as you've probably seen in some other places, we've used to test the aerodynamics of suits for some of our athletes. We've also used this facility to interface not only with the biokinetics people, but with the games people on faculty, so that these people can be using virtual reality and pretending to be in a fire, and then monitoring their responses and their decision-making as a result of extreme conditions. So we can vary both the conditions, and we can also vary the visual stimulation in the experiment. So we have quite a vigorous research program in a number of interesting areas, trying to develop new knowledge. We have specifically developed an innovation center, which we call the Brilliant Catalyst. And this is a picture of it from our atrium. So this is an inside view. This is a room which takes up most of a hallway. This is look at it from the outside with the sign Brilliant Catalyst, and there's the entrance. And this is an incubator where we are trying to bring together industry, local organization, and so forth, anybody with a good idea out there, and partner them with students and faculty to help develop that idea. Part of it is to get an idea off the ground for an industry or organization that maybe doesn't quite have the resources to get it to a point where they can get full funding, or perhaps it is an idea by a student who wants to develop a spin-off company, or so become an entrepreneur. So we're trying to develop innovative thinking in this facility. The faculty becomes involved, so the local organizations will pitch the idea to the university. The university will then go and try to find faculty and students who will work on this, work on these ideas in collaboration with the partner. Now, the original and are still part of our vision when we were on UOIT, University of Ontario Institute of Technology. The tagline was communicate, innovate, and connect. And I think that's exactly what we need to do to drive our innovation. Our main product is innovative students, and this is hopefully the way we can do it. Communicate and connect. This brilliant catalyst is one of the mechanisms by which we hope to attract people to give us the ideas, or pardon me, the topics from which we can build innovative ideas. So I think I'll leave it there. This is our famous picture of our library. We're now looking at the library from the Energy Research Center across the pool. Nighttime view of our architectural award-winning library. Thank you.
Thank you, Dr. Ikeda. That was a very interesting perspective, and having been in the industry, I can certainly vouch for the fact that your product of innovative students coming out of the Ontario Tech is visible. We can see that in the new grads that are coming out of that university into our industry. So thank you so much for that. So folks, you've heard a lot of different perspectives. You've heard from the operator utility perspective from Carla. You've heard a vendor perspective from Jeff. You've heard the Crown Corp perspective from Alastair, and academia perspective as well from Dr. Ikeda. I'll open it up to questions. Please feel free to throw your questions into the chat. To get the conversation going, I'll start off with one of my own, and I'll ask maybe Jeff if you could lead us off on this one, and perhaps Carla. I noticed your backgrounds are quite varied. So you've done things with engineering and operations and contracts and projects, and now waste management. Do you think there are any special considerations to going about being innovative when it comes to waste management, as opposed to being innovative in projects, for example, or is it all the same? And maybe Jeff, I'll ask you to lead us off there.
Okay, thank you, Bharath. Yeah, I think it's a great question, and certainly, one I'm familiar with, having just transitioned from the operating, generating side of the equation to the waste management, decommissioning side of the equation. I'll offer something of an anecdote that I've learned in my last few months on working with Energy Solutions. The first is I was at a plant walk down for one of the facilities, formerly operating nuclear power plant facility that we were decommissioning. And I was walking through with one of my team that was leading elements of the decommissioning effort. And we're coming through a particular area of the plant, and we're looking at some equipment. And so I asked a question about, there was a particular pump. I think it may have been a circ water pump or something like that. And I asked a question about, well, how do you get that out? Do you take this thing off and all that? And he said, well, you're looking at it all wrong. And I said, what do you mean? He goes, well, that's not a pump. That's rad waste. And it was one of those succinct little statements that at first I didn't understand what he meant. And then the more I dwelt on it, the more I understood that, through 30 years of my career, I've been designing and building and operating and maintaining plant equipment as equipment, pumps and motors and turbines and all variety of control systems and instrumentation. But as you step into the decommissioning side of the business, the waste management side of the business, it's no longer a pump. It's no longer a turbine. It's no longer a building. It's rad waste. And while that sounds obvious, I recognize that. What it does, though, is to change the lenses of how you see that equipment, that material, changes your entire outlook in terms of how you think about solving the problem of dismantling and decontaminating and decommissioning the facility. So when part of what you have to do is, at least for me as an engineer and a project manager, is you have to stop looking at it like it's a piece of functioning equipment, and you have to start thinking of it as it's a collection of material that you need to get out in the most efficient, low dose manner that you can, in a maximally characterized and segmented form that improves your ability to dispose of it in the most efficient, safe, and low dose way possible. So it's a really different framework. You think project's a project, decommissioning is just like building, except in reverse, but it does require a change in mindset. So that I would say that's one thing that I've learned and seen in my experience so far on this side of the business.
Thank you, Jeff. And Carla, your take on that?
Well, I like to acknowledge that Jeff and I both worked on the first unit. We were both leaders on the first unit of the Darlington refurbishment project, which was quite successful. At least we think so, right, Jeff? And that both of us have ended up in the decommissioning and waste part of the life cycle is, I think, a testament. And I think we're going to bring new ideas and new ways of thinking. But when I think back to our project work on the Darlington project, a lot of it was still around how do we minimize, the waste that was coming out of the reactors, because we knew that we didn't want to create this long-term situation. So, and I think Jeff fails to mention too his innovative approach that of the things he learned from that project, because now he's involved in a project with Ontario Power Generation to take the reactor components, the feeder pipes that we took out of that reactor, and we actually, made them smaller, reduced them in size as we were doing it. But now they've come back and said, okay, let's think about how we can further minimize that and apply sort of these innovative decontamination processes around it. And so they've launched a project, and in fact, out of 40 megatons volume, the waste component was only like two megatons. So the amount of reduction is really a testament to learning from one project, taking that information to another project and kind of continuously advancing it, because it's all fits together. So both of us have a lot of history in that. And running large mega projects, particularly nuclear projects, you learn to be pretty innovative on a day-to-day basis, right? So we're taking that and putting it into the planning process now of these future large complex projects around decommissioning. So that's what I would say about our experience being on these large other projects and how we're going to bring them to these new projects.
Thank you. Thank you, Carla. I'll take a question from the chat here. And I think, Dr. Ikeda, this is for you. The pictures of the campus clearly were very appealing, and they did the job that you were looking for. So we have somebody reaching out and saying, I have a few ideas, innovative ideas relevant to nuclear waste. Could Dr. Ikeda please walk us through the process of contacting UIT? And I'll broaden that a little bit more as you take a stab at that answer, Dr. Ikeda, to ask, how do we promote collaboration across the industry, academia as well? So please go ahead.
Okay. We have a lot of information on the website. Some of it is really hard to find. I find, I don't know if you have found, Bharath, but it's usually easier to go to Google and try to find it from Google rather than to try and come to our website and find it. But the contact at Ontario Tech for the Brilliant Catalyst is I've lost it now. There it's under contacts. Osman Hamid, and if the person would like to send me an email, I can get them in touch with it. With that person. I can also discuss the ideas with them. I'd be happy to talk to anybody about some possibilities. the question of how can we get some universities more widely involved in it is, well, I think there's two parts to this. One is from an industry perspective, we're academics, and we tend to be rather insulated. I mean, that's one of the things I noticed when I left AECL is suddenly we're in this little community, and some of the links to our outside friends are a little bit less, are a little bit more tenuous. Partly because we're running around like chickens with our heads cut off half the time, trying to keep up with the work the students give us. So what we certainly at Ontario Tech in the nuclear faculty, what we like is we would like you to come to us with some areas that you're interested in, because there's lots of people here who would just love to get started on some work, but we don't know where you want work done. Ideas are not something we're short on. Relevant ideas is something we don't have a good clue about. Okay, so for industry, you need to come. Not need to, but if you want us to get engaged, please come to us and pitch us with some stuff, and we're eager to do some work for you. And then there's the other side of it, which I think is very important today, is the public relations side of it. And I think that we need to encourage our communities to come to the university and ask people to come out and talk to them. So when you go out and you're trying to sell or explain something about a waste problem that you have, and you do a great job, don't get me wrong, you do a great job, but sometimes they want to hear it from somebody else. And, point to us. Get them to get in touch with us. We have lots of people. It doesn't have to be me. We've got a few other people around who can talk about different things related to waste and decommissioning. So, but we don't know where to go unless somebody asks us to come.
Perfect. That sounds like that's a win-win matchup right there from this panel. So I think we're being flagged with the time left here. But thank you so much to our panelists for sharing a little bit of what you are working on. Very exciting, innovative ways of addressing waste management here. I will encourage the audience members. I noticed there were a few more questions that came in towards the end. Please feel free to reach out to our panelists and have your questions answered offline as well. But thank you very much for attending, and hope everybody learned something new today.
Thank you.
Thank you very much.
Thank you.
Thank you.
Thank you so much, Bharath. There's lots of exciting innovation happening in waste management, and we look forward to seeing what it will yield in the future.